We're halfway through the mean stack right now. We've discussed Node.js and Express.js, but truckers, don't be fooled. There's still a lot left in here. We're going to be working our way up now to our persistence solution, MongoDB. Now, we're beginning to see how these individual pieces, this individual bucket of bolts, is actually strung together. So we now have a platform in place, we now have a web server in place that, as we discussed, largely provides us with our RESTful endpoints. But those RESTful endpoints are no good unless they actually have some persistence associated with them, and so that is what MongoDB brings to the party. Now, let me be very clear about this. I don't know who keeps spreading these nasty rumors, but NoSQL is not what you get when you let your DBAs drink on the job. Let me be very clear about this. I don't know who keeps spreading this awful rumor, but drunken DBAs are not the reason we have NoSQL out there. I kind of like NoSQL, and that doesn't make me a relational database hater. But one thing I will say, when I look at a relational database on a diagram, you all see this, and that's fine. Relational databases have been a very powerful persistence solution for us. As a matter of fact, I literally can't imagine a time when relational databases haven't been around. They've got introduced in the late 60s, early 70s, and they've been with us ever since. And while they're a very well understood persistence solution, in fact, there's a reason why we use that cylinder to represent them on all of our diagrams. Because relational databases are, in fact, a silo of information. Now, why do I call this a silo of information? Well, because this is the language you use to interact with your database. What language is this? Well, it's SQL, of course, right? And there's nothing wrong with SQL. It's a very tight, concise, expressive language, but are you writing your entire application in SQL? Well, if you're an Oracle DBA, I'm going to ask you to put your hand down. SQL is not appropriate for writing operating systems or applications. It's entirely appropriate for querying data out of your database. But if you have to keep two languages in your head, like SQL or Java, or SQL or Ruby, or SQL or JavaScript, I would argue that's one language too many to be dealing with. And I'm not alone in this feeling. There are a number of different ORMs out there, ORM, object relational mappers, which in fact are libraries that do exactly that, that translate SQL into Java or translate SQL into Ruby or JavaScript. A good friend of mine, Ted Neward, is famous for coining this little kernel of wisdom right here, that ORM, object relational mapping, is the Vietnam of computer science. You can see Ted and I go to the same barber. And Ted really struck a nerve with this. His analogy is that, well, Vietnam, we thought this was a simple war. We thought this was a tiny little third world country. We'll throw a couple advisors at the problem and we'll be done. But in fact, we got more and more entrenched and we were there for years. How does that relate to ORM? Well, we've got a number of really good libraries out there, and let me be very clear, these are very good libraries. I can't imagine being a Java developer without having Hibernate or something that gives me these same ORM capabilities. I wrote the OpenJPA courseware for Sun back in the day, so I'm very familiar with Java persistence in general right there. When we're talking about Grails, it's hard to talk about Grails without discussing GORM, the Grails object relational mapper. Of course, if you're a Rails developer, you're very familiar with Active Record or Active Resource. You can see this is a well understood problem and, believe it or not, a fairly well solved problem. But here's the problem. With all due respect to these ORM library authors, in their mind they think this is what they're writing, when in reality this is a little bit closer to what they're writing. A very simple library that does its best to bridge over these leaky abstractions, but at some point you can't bridge over the differences between a fundamentally object-related system and a fundamentally relational-based system. Remember the class-based inheritance we were talking about earlier? Class person, class employee extends person, class hourly employee extends person. That is very natural. As a matter of fact, that is how you define those relationships in an object-oriented language. How do you represent those same relationships in a relational database? You can't have tables extending other tables in a relational database. It's fundamentally set-based, not class-oriented. So you end up with compromises, and that's the polite way of putting it. How would I represent a person, employee, hourly employee hierarchy in a relational database? Well, I have a couple of options. One is to do a table per hierarchy, which means you have all the columns associated with a person, and then you have a series of nullable optional columns associated with an hourly employee. And then you have a different set of nullable optional columns for a salaried employee. Does that make you feel a little bit dirty even talking about it? Yeah, it should. Me too. That's not the ideal solution, because then you might have required fields on an hourly employee, like their hourly rate. You might have required fields on a salary employee, like their annual salary. And in a table per hierarchy, you can't enforce required fields on one of the child classes. So rather than dealing with a table per hierarchy, you might deal with a table per class scenario, where you have a person table that has a one-to-one relationship with an employee table and has a one-to-one relationship with an hourly employee table. And while that's an okay solution as well, then you're dealing with joins all the way down. And so you can see the idea behind ORMs, well, while they appear very simple at the very beginning, they're trying to bridge fundamentally disparate systems. And at some point down the line, and not way down the line, not an edge case, but very early on, you'll see where these ORMs, in fact, fall down. So am I here to tell you then that relational databases are evil? You should purge them from your code base and only focus on NoSQL solutions moving forward? No. You heard me at the very beginning of this presentation when I said that if you put a tool before a solution, you've already lost the battle. We need to look at what solution we're trying to solve and then choose the appropriate tool for the job. So I'm a big fan of the definition of NoSQL that's not SQL, but in fact not only SQL. Very often I'll say that relational databases are good for what relational databases are good for. And what I mean by that tautology is that if you've got data that's naturally row-oriented, that's naturally set-based, that needs the high transactionality but needs the strong typing of a relational database, then you've got a perfect solution, one that's well vetted and one that's been around for almost 50 years. Use the right tool for the job. But we find that many times the relational database is not the right tool for the job. It's in fact the golden hammer we have in our toolkit. And we stop looking for nails and just assume that the relational database is proper for all persistence challenges we have ahead of us. So that's why this whole crop of NoSQL solutions has popped up. And even though we lump them all under the same generic umbrella of NoSQL, we'll find that these are very different libraries that have very different sets of strengths and weaknesses. Now, we're going to be focusing on MongoDB, of course. Mongo is the M in mean, but Mongo is also short for humongous databases. That's how this particular library was named. Couch is a cluster of unreliable commodity hardware. Couch, a cluster of unreliable commodity hardware, defines what its mission statement is as well. And then there's Cassandra, and oh, I love this one. If you know your Greek mythology, you know the story of Cassandra. She was dating Apollo, and when you're dating a Greek god, it's a good thing. Apollo gave her the ability to see the future. The problem is breaking up with a Greek god is not a party by any stretch. And so when she broke up with Apollo, she couldn't just give him his class ring back. And in fact, he let her keep her superpowers. He didn't take away her power to see the future. He said everyone in her village would no longer believe her predictions and premonitions. Wow, that's an ugly breakup, isn't it? That would almost be like someone back in the 1990s claiming that document databases are going to be popular one day. Who would believe that? Yeah? Lotus Notes has been around since the 1990s. It is an absolutely dynamite document database. Now, if you're cringing right now because you've been using it as a mail client, I feel your pain. It's not a good mail client, but it is an outstanding document database. One that has synchronization absolutely nailed and has had it dialed in for 20 years. As a matter of fact, just like Mozilla Firefox rose from the ashes of Netscape Navigator, an open source solution jumping out of a proprietary set of bones, our good friend CouchDB leapt from the ashes of Lotus Notes. CouchDB is in fact the open source version of Lotus Notes. But what we find in these NoSQL solutions is that while we can talk about them in a generic sense, each one has its own particular strength or weakness. There are columnar databases like Cassandra. There are document databases like Lotus Notes, like Couch, like Mongo. There are key value pairs. We end up using something like React or Redis as simple caching solutions because they do key value pairs so well. We end up using things like Couch and Mongo because they do documents so well. We end up using Cassandra because it does columns so well. But once again, we need to make sure that our solution matches the problem set. So if you have data that's naturally row and column oriented, if you like SQL, if you're comfortable with these verbs, well then continue, please, with my permission. Use a relational database. It is truly the best solution for that particular set of requirements. But if your data tends to be more vertically oriented than horizontally oriented, it tends to be more document oriented than row oriented. If you're using JavaScript in other tiers of your application and you want to bring a consistent language across all those tiers. If you want to put RESTful verbs instead of your persistent store like post and get and put and delete, as opposed to SQL verbs like insert and select, update and delete, then you should consider a document database, and consider it because it's not the hot new thing. It's not giving you hipster credibility or buzzword compliance. You're considering it because, in fact, it's the right tool for the job. So I feel so passionate about this point that I'm going to give it again. Reuse is not just for software, right? We get slide reuse as well in here, that in software development, I can't emphasize this enough. You have to focus on the solution and bring the tools that best solve the problem, not the other way around. And in that spirit, relational databases tend to be one of the biggest golden hammers I encounter as I move from client to client. Not that it's not good for what it does, but sometimes you're using a golden hammer to drive screws, and it's clearly not the right tool for the job.